Good morning, ladies and gentlemen. Today I'm going to present my project in the topic the application of using light sensor from smartphone to measure the illuminance of light and turbidity of the water. Presented by Natchanan from St. Mara Chuti School and my advisor, Associate Professor Dr. Chinarong Siri Sathit-Kun from Parilat University. This is my outline. Introduction. Solution and suspension are widely used in medical and environmental industry, and the important properties of solution and suspension are turbidity. But unfortunately, the expensive turbidity meter is not widely available, unlike the devices from smartphone which are easy to access and use, and therefore the smartphone can be developed into various equipment tools. And my objective is to compare the efficiency of using the light sensor from smartphone to measure the illuminance of light compared with the standard lux meter, and to compare the illuminance measured by the light sensor using different smartphone and using different applications, and to compare the illuminance of light that passes through the solution measured by the smartphone with the turbidity of the solution measured by the turbidity meter. And come to my theory about the accuracy and the precision. Accuracy refers to the closeness of the measure wall with the no wall. This is referred to when I use the light sensors from smartphone compared to the standard lux meter, and the precision is referred to the closeness of the two or more measure wall to each other, and this precision refers to when I change the smartphone and when I change the application. The theory about the illuminance. E is the illuminance, which is the luminous spark incident on the surface, is equal to I, which is intensity divided by R squared when R is the distance from the light source, and the inverse square law of light intensity, I equal to L, which is the luminosity, which is the total amount of energy emitted per unit of time by the light source, divided by 4 pi R squared. And the theory about the turbidity. Turbidity is the reduction in the water clarity because of the percent of the suspended matter absorbing or scattering the traveling light. And this is the photo that shows that the light beam, which is the incident light that hit the suspended matter, the light will decrease in intensity. So this equation, Is is the intensity of the scattered light, is equal to V squared when V is the volume of the suspended matter divided by L power the fourth when L is the wavelength of the light beam, and multiplied by N when N is the number of the suspended matter. And this photo shows that the Is equal to I0 when I0 is the intensity of the incident light minus I when I is the intensity of the transmitted light. And in my work I can got the I, which is the intensity of the transmitted light, and then I combine these two equations, so I got this equation compared to the linear function equation. I equal to I0 minus V squared divided by L power the fourth multiple N. I is Y in the linear function, and I0 is C in the linear function. V squared divided by L power the fourth is the slope in linear function, and N is X. So theory about the turbidity versus the light intensity. From their work, they found that the turbidity and the light intensity had a linear relationship. When the light intensity increases, the turbidity will decrease. So my hypothesis, The light sensor from smartphone can measure the light illuminance comparable to the standard lux meter. And 2. The measurement using the same smartphone on two different equations has more precision than those using the two different smartphones on same application. And 3. When increasing the concentration of the solution and increasing the turbidity of the solution, the smartphone will detect the linear reduction of the illuminance of light passing through the solution. So this is all my equipment: the 100 watt lamp, 11 watt lamp, smartphone's acrylic box, weighing machine, beaker, measuring tape, lux meter application, sugar, and turbidity meter. So this is my methodology. Part 1. Using the light sensor from smartphone and lux meter to measure the illuminance of light of the varying distance and convert the illuminance to the light intensity, and found the relationship between the light intensity with the inverse fraction of the distance square from the light source. So part 2. Using the two different illuminance measuring application on the same smartphone to measure the illuminance of 11 watt lamp with a varying distance, and find the relationship between the light intensity and the inverse fraction of the distance square from the light source, and follow step 1 and step 2 by changing the smartphone by using the same application. So part 3. Using the smartphone to measure the illuminance of light that's shining through a sugar solution at a varying concentration, and plot a graph of the relationship between the light intensity that's shining through a sugar solution with the concentration of the solution, and use the turbidity meter to measure the turbidity of the with varying concentration of the solution, and then find the relationship between the intensity and the turbidity of the solution. So this is my result. Part 1. This graph shows the inverse fraction square of the distance from the light source with the light intensity. I found that the light intensity will increase when the inverse fraction square of the distance from the light source is increased, and the blue line show the data from smartphone, and the yellow line show data from lab meter, and these two lines have a closed slope. So part 2. Measuring the illuminance of light by light sensor from smartphone. This graph is a relationship between the inverse fraction square of the distance from the light source with the light intensity, and these three lines show the closed slope, but the yellow line and the red line is at the closer wall. When the yellow line is smartphone 1 application 1 and red line is smartphone 1 application 2. And part 3. I found a relationship between the concentration and the illuminance. I found that the illuminance will decrease when the concentration is increased, and it has a linear relationship. And the relationship between the illuminance and the turbidity, I found that the turbidity is decreased when the illuminance is increased in the linear function. So come to my conclusion. Part 1. The light sensor from smartphone can measure the illuminance of light comparable to the lux meter because the slope of the graph of the data from smartphone and data from lux meter has the closed wall. And part 2. A measurement using the same smartphone with two different applications has more precision than those using the same application on different smartphones. because the slope of the graph when changing the application on same smartphone has more closer while than changing the smartphone with the same application. And part 3, when increasing the concentration of the solution, the illuminance of the light that's shining through the solution is decreased, and exactly the turbidity of the solution will decrease when the concentration increase, and the relationship between the turbidity and the intensity is the linear function because the illuminance of light that's shining through the solution is decreased when the turbidity of the solution is increased. So, the end of my presentation. Acknowledgement. Thank you, Associate Professor Dr. Chinarong Siri Sathit-Kun, School of School of Science, Walirak University, and Teacher Samani Jemamat, Department of Science, Natchanan School, and thank you DPST and IPST. Thank you for your attention. Questions and suggestions are welcome. Thank you.